Good morning. I am Mrudula from MTech Mechatronics Department from VIT University, Chennai. The topic of my seminar is CompactRIO, also known as Compact Real-Time Input-Output DAC devices, and it is one of the important DAC cards which has been introduced by the National Instruments. The CompactRIO or CRIO is a real-time embedded system controller made by National Instruments for industrial control systems. The industrial control systems or ICS is a general term that tells us about various types of control systems in an industrial process, including a supervisory system, a control and data acquisition system like a SCADA system, and a distributed control system, also known as a DCS system. The SCADA system simply means a supervisory control and data acquisition system. And by a supervisory control, we mean that a system that can be established in industrial areas and in some areas which are non-accessible to human beings, such as over a satellite or over the mountains where human population cannot go and check out, and in some other areas where machine vision systems are required but human interaction is not possible. So industrial control systems may also consist of a number of PLC and automation systems also. The CompactRIO is a combination of a real-time controller, a configurable input-output module, also known as a RIO, an FPGA module, and an Ethernet expansion chassis. The Ethernet expansion chassis is sometimes used to connect the module with the outer internet systems. Now let us discuss about the hardware of the CRIO system. The main hardware of the CRIO system consists of a real-time controller, a reconfigurable chassis, and input-output modules. A real-time controller can be explained as it consists of a powerful processor with a wide range of clock frequencies. And by the meaning of clock frequencies, we can say that there is a separate frequency for the input data and a separate frequency for the output data. And these input and output data need to have different clock frequencies so that while working them out in a full duplex system, that is when a listener and a talker are both acting at the same time, there is no interference in the system and the data does not get overlapped. So in that cases, we need a number of different amounts of frequencies, and this is used, and these frequencies are brought about by using a real-time controller. And the next module is an FPGA module, which is also known as the input-output module. The FPGA module, as the name suggests, is a gated array module, and these modules can either be connected in series or in parallel systems for the SCADA system to explore. And the FPGA systems can be programmed using LabVIEW. And about LabVIEW, I'll be discussing it in the software section of the seminar. And the FPGA controller can be programmed separately and is connected to the real-time controller using an internal bus. And this internal bus can be a GPIO system or an HS488 system on its own. The input-output modules are C-series cards made by the National Instruments themselves. And these C-series cards are an earlier generation of the GPIB cards. And it is called an earlier generation because upon bringing the disadvantages from these C-series cards, the GPIB bus system has been developed. And these modules are not swappable. That is, the clock module is supposed to be at the clock position and the input-output module is supposed to be at the input-output position, and their positions cannot be interchanged. The Ethernet expansion chassis comes with an Ethernet port, and the order of the Ethernet port is 8P8C, and it cannot be connected to LAN or any other systems. And the CRIO can be used to connect to the host PC using this Ethernet system only. And the chassis comes in two formats, namely a 4-slot format and an 8-slot format. The FPGA is connected to the real-time controller by a high-speed PCI bus. And by PCI bus, we mean that it is a parallel control interfacing bus. Software. Now let us discuss about the softwares which can be used to control the CRIO. Since the CRIO is made by National Instruments, the real-time controller can be programmed by a software developed by National Instruments itself. And one of the best compatible software for this process is the LabVIEW. And LabVIEW can be considered as a virtual network which acts as a bench to design a platform or environment which is used for visual programming. Both and everything can be done to the front. front panel, and the similar indicators can be used in the back panel, and they can be connected to develop a software which connects the modules of the system. The hardware modules are connected to one another of the CRIO system using the LabVIEW software itself. In real-time controller, there is a licensed version of RTOS VxWorks, and by RTOS VxWorks we can say that it is a VxWorks system which is present in real-time operating systems, and VxWorks, as we know, has already been developed by the National Instruments. So whatever has been developed by National Instruments can be compatible with each other for helping out the CRIO systems. The Xilinx FPGA is used in programming the Xilinx chain, and Xilinx is a programmable system, and it is also a graphical user interface. And the programs created in LabVIEW are compiled into machine code for VxWorks and hardware description language. It can also be used for Verilog systems. VxWorks running in the real-time controller supports a file system, and hence minimal data logging is also available in the controller level. A full development system version of LabVIEW comes with modules needed to program for the CRIO. That is only a particular part, like in different modules such as the fuzzy module or the neural network module are not required for programming CRIO version of the system. The programming is done on a host PC running with the Windows or nearly a Windows Vista version or any other Windows 7 or Windows 8 version, which is mandatory for programming the CRIO systems. The lower versions cannot be used. Applications. The CRIO systems are commonly used as headless systems, and by headless systems we mean that without a user interface. That is, a user interaction with the system is not always required. You have to give the base value, recreate its value, it creates its own path and does its own surveillance issues, and it does not require a human interface at every other end. And because of this, it is more flexible to run in confined spaces and under very harsh conditions. Hence, it is known as a very rugged operating system or an input-output system. A CRIO can be connected to a host PC, which can be used for supervisory purposes for displaying the log data, and this connection is brought to us by IEEE 488 or any other common bus systems. And sometimes video surveillance can also be done in these systems by using built-in video graphics array. And VGA graphics does not have a very high quality, but the low quality used in monitoring the inaccessibility such as mountainous areas or in army camps, etc. One of the easiest application or one of the most common application of CRIO was in the first robotics competition, and by the FRC we mean that it was a literal first robotics competition. It appeared in schools where about huge robots were used. These robots were sent to competitions such as scoring balls in goals, frisbees, inner tube on racks, hanging on bars, balancing robots on balance beams. And to check out all this system, these FPGA and as well as the VGA cameras were used to take a look using the systems. Let us discuss about the processor performance of the CRIO system. It can be used in a dual-core processor of 667 MHz, and it can be used up to 1.33 GHz dual-core. It can take place in the Mac systems, but it cannot work in environments of lower versions of Windows. It needs at least a Vista or a higher performance window. The operating system has to be a real-time operating system or a Windows or any other operating system. It can be Macintosh also, but it has to be developed more. The size may vary from 1.7 to 9.3 to 8.3 centimeter cube. Its volume can range from a small box or a small rack of books to a huge system that can accommodate a number of PLCs together. The target applications can be said that it is used in a smart grid analyzer. It is used in departments of power electronics and laboratories, power monitoring, structural monitoring, mobile robots. Mobile robots also in the case of robots which are used in surveillance and rugged areas. And higher versions are used for machine vision, automated welding controls, prototyping, turbine control, etc. Thank you.